And then the first page is just a bunch of notations, things that we see throughout the module that I want to make sure we're all squared up. So 1, 2, and 3, we talked about how all of those little notations above those two letters look similar. Make this even bigger so we can see this good at home because the arrows aren't particularly big. But if you look at letter A, B, or number 1 with the letters A, B, and we have this line on top, notice how there's no arrows there? When we have a line that has an endpoint on both ends, what we call that is a segment. So in terms of what this would be called, this would be segment A, B. That's how that would get read. I ask you to then draw what that figure would mean. So if I were to ask you to draw this, it would be a segment that has a starting point and an ending point. One of them has to be A, one of them has to be B. So that's what segment AB would look like. Number 2, when you see arrows at the end of them, both of them, that's when we actually can now use the word line. So line CD. When we now draw this in, go ahead and draw your line. We can't put the A and the B on the arrows, so we just put them somewhere in between. Or sorry, C and D, not A and B anymore. That's line CD, and that just means we go on left forever in both directions and to the right. Number 3 is now kind of the combo of those. We don't have an arrow on this end, but we do have an arrow on this, and I know it's pretty small at home. So one has one doesn't. So what this is a ray. The order of 1 and 2 don't matter. So I really could have called this segment AB or segment BA. The order doesn't matter for a segment. It doesn't matter for this line. So I could have also have called this, if I would have rearranged those letters, I could have called it line DC. So those it doesn't matter. This it does. So this is a ray. Since E is our initial point, that's where we start. And then F is the point that goes on forever, or the side of our line that goes on forever. We have to go ray EF. We wouldn't want to call that ray FE. The first one implies that's where we start, and then the second one is the one that we continue on through forever. So to call this one, you're going to have a distinct starting point at E, and then our line F. Don't put your F on the arrow, just put it to the right of E. That's ray E going all the way through F forever, okay? So keep those straight. That's probably what we see the most that you just need to make sure we're squared away on. When you look at number 4, look pretty similar. This is just read as angle GHI. If I ask you to draw that in, then you basically, the reason this looks like this is because that's what we would largely draw in. That's how we can draw an angle. So just make what would look like an angle, and then H has to be the vertex here. And then we do GHI. All right, so that's what that would look like. Number 5, similar. When we put this in front of it, what that little M is telling you to do is we are now solving a problem. We are now looking for the measure of angle JKL. You don't necessarily need to draw this, but this is now a degree measure. All right, what is the 30 degrees, 40 degree measure of the angle that you're talking about? 6 is triangle MNO. So when you see that in front of it, that's just talking about triangle MNO. And then we would draw a triangle. One vertex has to be M, the other one N, and the last one would need to be a 0 or an O. So those letters indicate the vertices of the triangle. This you would have ran into a little bit in the past. I know in Math 1 we do this. This little symbol here is read as perpendicular. Oops. I'm not an English major, as you can see, so perpendicular. So if you ever see that little symbol, it means we're perpendicular. If you ever see these two little guys, that means parallel, because we have two lines that are both parallel to each other. And then now, I kind of wish I would have put 9 up here with 1 and 3, because doesn't 1, 2, and 3 look very, very similar to number 9, except there is no little line or a segment or a ray over the top. When there is nothing over the top, that's not a mistake. So when you don't see anything over the top of this, what that is asking you to find is the length of that segment PQ. So when there's nothing on top, that's now us solving a problem and finding the length of that segment, okay? All right, so with all of the, oh yeah, and then one more. This one we should know. You saw that a little bit last year. We've been talking about it a lot this year. This means congruent. And that means, it doesn't mean equal. It means that the angles have the same degree measure, or the sides have the same lengths. They're not necessarily the same angle. They just have the same degree measure. All right. So if I now give you this, you're going to do the opposite. So given this figure, write the name of the object using the letters in the picture. So if this is our picture, what we have created based upon the first 10 things that we did at the top of the page. Did I miss some numbers here? Why did I number weird? Yeah, I don't know. So go to 13. This is an angle. And then the way this angle has to be named, the only thing that has to be true is when we name these three, the F has to be in the middle. I'm going to go K, F, D, but there's not anything stopping us from going D, F, K. 14. Write down 14. Write down what you think 14 is. All right. If you look up at number 3 at the top of the paper, notice how on number 3 you have one endpoint, one that goes on forever. So this is what we would call a ray. G is where this starts. And then E is where we continue on through. So you're going to do that. So given that figure, write the name of the object. That's what we have right here. This is ray, G, E. Then 15 is kind of self-explanatory. My guess is that's what I wanted for 11 and 12. This is point. When you just see this guy, point R. A lot of times that's used in our circles when you're told you have a center of a circle. That little dot is just our center. So that's our point. All right, then let's get some of these problems. So a lot of these, so the ones tomorrow, don't mess these up. These are our nicest, easiest ones that I think everybody's understanding. That inside of a triangle, the angles always add up to be 180 degrees. Now, there's a whole lot of different ways to ask that and apply that, but we should know that. So if I give you number 17, if I ask you to solve for x right here, notice how we have the 3 angles of a triangle. Well, if all 3 angles add up to be 180, that's what we're going to be doing. We're going to take this angle here. We're going to add it to this angle here. And then we're going to add those two to the third angle, 10x plus 2. And when we do that, we know that those have to add up to be 180 degrees. Then you've got to be able to solve this equation. I'm looking at the homeworks from the other night. There's a few of us who set these up right, and then we just have a little trouble solving these equations. So this is something we got to be able to do in terms of the algebra with this. When they're on the same side of our equal sign, you're combining like terms. So the 2x, the 4x, and the 10x, and we add all of them, give us 16x. Then we have a positive 2 and a positive 2 together equals 4. Then that equals 180. Then from here, we're all pretty good. Subtract your 4 over. Divide. And then x should be 11. Now, tomorrow, again, be very, very careful. Know what I am asking for. Here I am asking for x. If I wanted to take this kind of up a notch, I could call this angle A, this angle B, and this angle C. And then I could ask you, all right, well, what is angle A? Then you've got to take this x value, plug it in to identify what angle A is. So each problem tomorrow, make sure you're answering the question and not just always solving for x. X will not always be your answer. Okay? All right, the next page. You're given triangle LMN. So LMN. That was the last problem, right? Yeah. Then you were told that angle L is 7x plus 2. Angle M is 2x plus 7. And then angle N is 2x minus 5. And then now this one is what I'm alluding to. I want you to find, this is read as the measure of angle M. So the answer to this question is, what is the degree measure of this? Well, we can't find that until we know what x value to plug in there. So it's now kind of the next step from number 17. You're going to do the exact same starting process where we're going to add all 3 of those angles up. And when we do that, we know they have to add up to be 180. And then combine your like terms. So we have 7, 9, 11 x's when we add up all of our x's. And then when we do our constants, the positive 2, the negative 5, and the 7 would make negative 4. So positive 4 equals 180. Solve this for x. So subtract our 4. 11x equals 176. Divide. It's got to be 16, right? Because we just did it before. Yeah, so x equals 16. In number 17, that was your answer. So on tomorrow's quiz, in 17, x is the answer. 18, though, we now need to take, just like I talked about in the previous one, take this x value, substitute it into that angle to identify what that angle degree measure would be. So you do 2 times 16 plus a 7. That should tell us that that is a 39-degree angle. Okay, so that's that. Number 19, the other one that we deal with a lot that hopefully we are seeing is that a straight angle, so just a straight line, always has a degree measure of 180 degrees. So both a triangle and a straight line. So for number 20, it says draw an example of each angle below with the given measurement and then extend that angle so that we have a straight angle and then tell me what the measurement of the next angle would have to be. So what this gets at is understand all of these are based off of understanding a 90-degree angle. So don't draw this yet. This is not what I want you to draw in. A 90-degree angle is that perfect T. So if this is a 65-degree angle, what you have to kind of understand is, would this guy be extended off in this direction? Or would it be extended here if we want it to be less than 90? So do that real quick. If this is 90 and we have 65, do we extend it up and left or up to the right to get a 65-degree angle? Good. And we haven't, I don't know when we'll talk about that. Good. Should be this guy, right? This would be a smaller angle than 90 degrees. If we go bigger, doesn't that make this a bigger angle? So if this was 90, let's get rid of the 90, then we would want that new angle to be less than 90. So that's what this would look like. So then label this as 65 degrees. Cam, you okay with that? Okay. All right. So now extend this line. And then now just tell me, what would this angle have to be? What would the missing angle, so that we get our nice linear pair there? Get out of the purple, it's a little hard to see. And then this is just this idea that they have to add up to be 180. So since we have 65, good. Fisher, thank you. Has to be 115. You take your 180, get rid of the 65 that we already know. Got to be a 115. Good. All right, so then 21, same idea. Don't draw all that out yet. If this is a 90-degree angle, and I want my angle to be bigger than 90, the way I'm going to make this angle bigger is by now moving it off in this direction. So this, we could say, could be a 180-degree angle. If we now straighten this line out to create a linear pair, then the question is just asking you to find then what would this degree measure have to be. Same thing we would have done before. Their total is 180. Subtract away what we currently have, and that's got to be, what, 52? So 52 degrees. Okay, so that's our linear pair idea. 22 is we've kind of added layers to this now. We now have multiple lines. Don't let any of those two things that we just did change. Focus on the ones that we're concerned about. The only line that really matters right here in terms of our 180 is this line right here. And then this angle. And then the angle that I'm asking you to find, this angle, have to add up to be 180. That's the diagonal line. This has to be 100, not 107. It has to be 77 degrees. right. All right, so 23, we can do that real quick. You just do your 180. We know the whole amount is 180. Subtract your 73. That should be, oh goodness, what is that, 107? So that should be 107 degrees. Now, as we do the next ones, now this requires our equations, the algebra, the solving, that process. But it still boils down to the idea that these two angles form this straight line right here. So when we take 7x and 8x plus 15, those guys now have to add up to give us that 180 degree overall that we get in a straight line. So we'll do 15x plus 15. Just go through the algebra here again, continue to solve this. So then our 15x equals 165. Divide by 15. X is 11. That's all I am asking for here. But again, I could very easily ask you for either one of these two angles. Okay, so just make sure you're answering the question. All right, 25. We're, again, I slowly but surely kind of up the ante each time, adding a different layer to this. If you look at 25, it's still nothing more than right here, this straight line is a 180 degree angle. The only difference with the previous few is that it is now comprised of not just one angle or two angles, but in order to get the straight line, we now have three, oops, that's not the color one. We now have three different angles. So now all three of those added together must equal 180, and then that's where you're going to get your equation from. All right, so let's move over here to where we have this. So we take the first angle, 7x minus 5, add it to the second angle, 93, and then add it to that third angle, 4x plus 15, knowing that when we do that, they have to equal 180 degrees. So we get what? 7x, 4x is 11x's. And then we get -5, 93, so 88. Is that 103? You guys got that? Okay, 103, and then that equals 180. Forced myself to do a lot of mental math today with not super easy numbers. All right, then let's subtract this over. Maybe I should have keyed this up beforehand. That's 177. Uh-oh, I don't like the look. Oh, 77, good. I like that much better. All right, because now x is going to be a 7. So if that's the answer, or if that's what the question is, that's your answer. So if A is what I had asked, you're good to go. If I ask you to find B, D, C, see if you can do that. See if you understand what angle am I asking for when I say B, D, C. I'm assuming a lot of us are pretty competent understanding this reasonably well. If you have B, D, C while we wait, go ahead and find letter C, A, D, E. All right, so then the measure of angle BDC, in terms of my colors, hopefully we can look at that and understand that BDC is the yellow angle that I have shaded. Go from B to D to C. So you're going to take this 7x minus 5 expression, and we're going to replace our 7, or our x, with the x value of 7 that we had solved it to be earlier. So 49 minus 5 should be 44 degrees. Angle ADE would have to now be the green section. So that's the 4x plus 15. We now know our x is a 7. So that should give us a 43 degree angle. Let me add one question. I haven't done this to you yet. Put a D real quick. Do this for me. See if it's more than anything understanding how we're naming angles. Find the measure of angle BDE. All right, while you do that, I'm going to fill in we had found the yellow section to be 44 degrees, and we found the green one to be 43 degrees. It's kind of the first time I've done this where it's not one of those just single angles. What do you think, Jenna? What'd you get? Good. So Jenna said 136 degrees, and what did you add together? Good. The 93 and the 43, because BDE gives us this big angle, and it's now a combination of here and here. All right. So that's why the name of these angles are important, so that we can understand the order in which we're going to go, so we know which angle we're talking about. All right. Good. All right. 26. Set that one up. How many do we got left? I want to make sure we don't. Yeah, we'll get through most of this, I think. And then we got 10 minutes. Yeah, go ahead and set that one up real quick. And it's just a different version of the previous question. And that's just what you have to kind of wrap your head around tomorrow when you're doing these. We're not going to throw anything new at you. It just may be a tweak, a little difference. So instead of giving you that angle, it's more than anything making sure you know how to name it. A, B, C, that is the one that we gave you. And then from there, it's the same exact thing you would have done in the previous problem. All three of those added together make this straight line. So that means when we add all three of them together, they've got to equal 180 degrees. All right, and then that's our equation. Okay, so then from there, we got what? 10x plus 90. Speed this up a little bit. Subtract your 90 over, and you should have gotten 9. And that's all I was asking for is the value of x. So then that's our answer. Okay. So here's what you want to be careful of. A lot of our equations, we are adding and setting equal to 180 degrees. That's with our triangles. That's with our lines. When we visit 27, we're now going to have something that's a little bit different. So we've talked about straight angles so far. We've talked about 180 degree angles so far. The third thing that we've talked about is the idea of vertical angles. So when two lines intersect, notice how we get one angle here. We get a second angle here. These will always create 4 different angles. The angles that are vertical are the ones that are opposite of each other, directly across from each other. So know what a vertical angle is. And then the big thing is knowing that vertical angles are congruent. Knowing that, doesn't that allow us to answer this guy very, very quickly without any work whatsoever? Because isn't y opposite of 152? So these are vertical angles of each other. So angle y would have to be the same exact thing as that blue angle. And then now for the first time, when we go to set up an equation, we're not going to be adding anything up and setting it equal to 180, although you could have, right? Could we have drawn a line right here? And couldn't I have said 14x plus 2 plus 152 gives me 180 degrees? That would work. So in all of these, there's a lot of options. What I'm going to do, though, is aren't the yellow and green angles vertical angles? They're directly across from each other. Those have to be equivalent. They have to be equal to each other. So now our equation would take the green angle, and we have to know then that that's equal to, the other angle. What did I do here? Yuck. That's definitely bad. That is not going to work. See, there's too many options here. What did I want that to be? 152, 150. Too clever there. You could. But I still don't think that works good though. 14. So we could definitely. Hey, is that your brother, Cam? Little sister. Okay, yeah, sister. Okay. All right, so we could add these together and set it equal to 180. Does that work better? 54. And then we get 14x to equal 26. That still doesn't work out good. That's a bad problem. I apologize. My guess is I wanted to put another number in there somehow. So let's get that guy. But just understand vertical angles, if they're directly across from each other, they're congruent. Okay? That's what happens when you put a bunch of problems together very quickly. All right, 28. This is now a new thing that we talked about. And this is the idea that if these two sides are congruent, we did a bunch of these yesterday, the angles opposite of each other are congruent. So what we can write down right away, even though it's not asked, we definitely know this has to be a 50-degree angle. Now all you have done is we've used the new property, the idea that two sides congruent, the opposite angles are congruent. We can now use that with what we've already done that I think most of us are pretty good with. Don't all three of those angles have to add up now to be 180 degrees? And we now know all three. So 7x plus 3 plus the 50 plus the 50 equals 180. There, this one I used some better numbers. So we get 7x equals 77, and our x is going to be 11. All right. All right, 29 I think is probably the hardest one we have today. 29 and 30 a little bit, because there's just a lot of things going on here. See if you can set up an equation to get 29 started. See if we can kind of put some ideas together. If this is on the quiz tomorrow, where can we start? What do we know? How could this problem get started? Yeah, we can do those a couple right before class tomorrow, actually. Fast. Okay, anybody have an equation they could share out that would get this guy started? Yeah, Cam? So to start off on solid two, like congruent lines or whatever. Good. So that means that we just said 4x plus 16 equals 7x minus 8. Good. So said it, yeah. So what he's saying is these are two sides that are congruent, so the angles opposite of them are congruent. So those have to be equal. So that gets us started to where we can now start to solve this equation. So I'm going to subtract 4x from both sides. Then we'll add the 8 over. And we get 3x to equal 24. And with this, we get our x value to be 8. All right. Then we need to figure out our y value. So now multiple steps that we need to kind of go through to now figure out our y value. That's nice that this gives us x, but now we still need to figure out our y. All right, anybody have thoughts on how we could start to work to figure out y? What's the next kind of domino that needs to fall? Yeah, go ahead, Cam. We plug in 8 to 4x plus 16 to figure out the two top. Good. So he said we're going to take this 8. You could plug it into either one of them, really. So he said 4x plus 16. You could use either, but he said 4x plus 16. So if I did now 4x plus 16, and let's let our x be the 8. This is 32 plus 16. That's 48. So what we find now is this angle here is 48. That also then tells us that this angle here is 48. All right, then what, Cam? Good. So what he just did is 180 for the inside of a triangle. Let's subtract away those two angles that we know. All right, what's that give us? 84. So we then know that this angle here is 84 degrees. So now we're actually at that angle. So then the last thing we need to do, Cam, is what? Not quite. You're so close, Cam. That was some fantastic stuff there. That's right. Maybe somebody could help you out. Yeah. The Bisher, you got Jenna and Ahmed here. You got any? Nora, I know Nora's a good math student. Nora and I go back a ways. Nobody? What'd you say, Ahmed? You got something? Yeah. You would, Nora. Thank you. Or, wait, why did I write 84? Yeah, 84. 84. Because doesn't this angle equal 84? And isn't the expression 9y minus 6? So doesn't 9y minus 6 have to equal 84? Our final equation. So 9y equals 90. Divide by 9. And y is a 10. And that's some good, solid math right there. All right, that's a lot of stuff going on to get through that problem. Okay, so good, both of you. All right, and Ahmed here in class. Okay, bring this tomorrow. I will do these. These last couple will go very, very quickly, and we'll review what supplement, complement mean. So we'll take 5 minutes to do these tomorrow. You could try. I wouldn't mind you trying 30. See if you can get through that one on your own. It'd be a good little task for you to see if you're ready to go tomorrow and put some of these ideas together. That's not an easy one either. Okay, but quiz tomorrow. Till then, have a good night. All right, we'll see you guys. No homework. Just be ready for your quiz. 35 minutes is like that. Like, man. It is. Bye, Jenna.